In this video, let us understand how do we solve for ABCD parameters and the condition of symmetry, verify the same over PSpice. I am Mohan BS, working as assistant professor in Department of EEE, SJVIT. So this is the circuit given where we have to find the ABCD parameters for the given network and show that the value of A and B both are same, thus the condition of symmetry is being satisfied. So here let us value them. We have assumed here all the resistance values are 3 ohms. Let's see how do we solve. So before we proceed further, these are the few applications of ABCD parameters which are also known as transmission line parameters. So in networks, analyzing two-port networks, simplifying for amplifiers, filters and transmission lines. Over control system, analyzing transfer function, stability for dynamic systems, representing for state space equations in a simplified form. In power system, model and engineering, representing analyzing the transmission line for power flows, impedance matching and fault analysis that you'll be learning in upcoming higher semesters. In mechanicals and structures, they actually represent the incorporate the data for vibrations and wave propagations in mechanical structures. So these are the applications of ABCD parameters. So we have the values. So what we have done here is I am assuming that this delta is converted to star. So you can pause the video and write down the formula. If we convert to delta to star, what are the answers for R1, R2, R3? And I think we are aware here at this point that R1, R2, R3 all are having same values because here all the three delta elements are being same value. So the answer is 1 ohm. So once we have known the values of equivalent star as 1 ohm, what do we do with these delta? We eliminate. So this is the circuit. This is the reduced circuit. Now from here, the transmission line parameters are given as V1 A V2 minus B V I2, I1 C V2 minus D I2. Right? So these are your two-port parameters with respect to transmission line parameters or ABCD parameters. Now what is ABCD? Now A is called as open circuit voltage ratio. It's a voltage ratio because it's of both are of same quantities, that is voltages. Now why it's called open circuit? It's called open circuit because current I2 is being made 0 to find the parameter A, right? So that's why it's called as open circuit. Similarly, C is also called as open circuit because I2 is made 0. So current is 0 only under open condition. Similarly, B and D are called short circuit because we are finding B and D only when V2 is made 0. So how is this end V2 is 0? Only when we short circuit. Right now V2 has some voltage. So we'll discuss some more later on, but as of now, to make V2 0, one has to short circuit at this end, right? So when V2 is 0, we can find B and D. I can see it is negative here, so that's why we have a negative short circuit. D also has negative, we have negative short circuit. Now it's a ratio of impedance. V by I is called as impedance or resistance. I by I is called as it's a ratio of current, right? So that's how these are named. So let's solve for A and C. So how do we solve for A and C? This I2 is assumed open, right? This V2 is as it is. This assumed we have some voltage applied here, some voltage V1. Let us apply KVL. When we apply KVL to this loop, we get I1 plus 4 I1 is equal to V1. So I1 plus 1 plus 3 comes 4 I1. So this I2 is 0, right? So the current is not entering to these two resistances, right? So there's only one current I1 flowing. So we can simplify this as V1 is equal to 5 I1. Let us rename this. Let us name this as equation 1. Then what is V2? So if we connect the voltmeter at this point to measure this voltage, which voltage does it read? I'll give you the answer and then explain. So when we connect a voltmeter, positive at this end and negative at this end, it gives voltage across this resistance. Now as there is no current flowing through this resistance, this is 0. So it measures voltage across these two. So V2 is simply voltage across this. And which current is flowing through this? I1. Now the equation, is it I1 into 4 or minus I1 into 4? Out of these two, which is correct? Pause the video, analyze for your answers. I hope you have got the answer. The correct answer is plus I1 into 4. Why? So this I2, this plus appears across here. This current I1 hits positive of V2, thus it is positive I1 into 4 and not minus I1 into 4. Thus we can rewrite the equation, above equation, as I1 is equal to V2 by 4, and I'm calling that as equation 2. Now I'm just rearranging equation 2, shifting this V2 towards the denominator. It represents I2 by V1, which is called as short circuit. You can see here it is negative C, right? It is, sorry, open circuit transfer admittance. It is 1 by 4, right? And it is admittance, so the unit is mho. Next, if I substitute the value of I1 here, if I substitute the equation 2 in equation 1, I get the answer for A parameter, right? So we know that V1 is 5 into I1, I1 is V2 by 4, so 5 into V2 by 4. And if I rearrange this, if I get this V2 at the numerator to denominator, we get V1 by V2, which is equal to 5 by 4, right? And this is our A parameter, which is nothing but open circuit voltage ratio, and it's of same quantity, so there's no unit. This is 5 by 4. So this is how we can solve for A and C by making I2 open. Now let's solve for B and D. So how do we solve for B and D? What should happen to V2? V2 should be 0, and when is voltage 0? Under short circuit, right? So with some voltage V1. Now let's apply current divider for I2. So what is the current divider equation for I2? So I2, we know current entering is equal to main current into opposite resistance divided by sum of the resistance. So this is the main current entering. So for this branch which is opposite, this which is 4 ohms, divided by sum of the resistance, that is 3 plus 1 4 plus this 1 ohm, not this, plus this. Why not this? Because we know already the current to this. So these two are the unknown branches. So main current into opposite branch where current is not known, divided by the sum of branches where the currents are not known. So 3 plus 1 becomes 4, and this 1 is entered here. So this equation is partially correct. I would say this equation as minus I2. As current is entering, we want this current. So for this I2, this equation is correct. I repeat, for this I2 which is going towards right, the current going towards right, for that this equation is correct. But what is the current going in opposite direction? I have to incorporate negative here. So I am shifting the negative towards here, it becomes minus I2. So minus I2, this is my equation. So simplifying this, minus I2 is equal to 4 by 5 I1. So rearranging this to get the parameter, the D parameter, we get I1 by minus I2 is equal to 5 by 4. It's a ratio of current, right? So that is negative short circuit current ratio. There's no unit because it's the same quantity. Next, let's find for B. Let's apply KVL in this loop. We get 4I1 plus 4I1 and plus 4I2. Why plus 4I2? Because I1 is flowing down here, I2 is also flowing down here. Thus both are positive in this case. So I'll simplify this. I'll call this as equation 1. And what do we know? We know in earlier case I1 by minus I2 is equal to 5 by 4, or we can write as I1 is equal to minus 5 by 4 I2. So I'll substitute this I1 in this equation 1. In place of I1, I'll substitute it as minus 5 by 4 I2. And as I simplify this and rearrange the equation for parameter B, we get it as 9 by 4. So V by I is. So let us see how do we simulate this 8th experiment to find ABCD parameters and to show that A and D are same. So this is a circuit. In theory class, for theoretical calculations, we have assumed R1, R2, R3, R4 all are equal. So this is how we connect. So in calculations, we have found A and C when I2 is equal to 0. So I2 is 0 means this has to be left open. Either you can leave open or connect a DC. 0 means you have to create open circuit. So connect a high value of resistance, or you can leave blank also. So making it as large as possible, and then what we must find for A, we must find V1 and V2. So V1 is our input voltage, V2 is the output voltage. So in the diagram you can see this is V1 over here and this is V2. So this is V1. So you can give any values. So I'll give my USN number 19. You can give any number, either positive or negative, any value you can give. And then since we know what is, we are giving input V1, so we need not find. So we have to find V2, go to marker, voltage differential, positive and negative. Why positive here and why negative here? You can see in the question, positive is here and negative is here, thus positive and negative. So the settings are setup analysis, click just enable transients, simulate for your output. So the output is 15.2. So let's note down here. So these are the values for theoretical calculations that we have got for ABCD. So for A, we are given input as 19 and the output is 15.2. So 19 by 15.2, we get same 1.25. The ratios are same for A. Now I2 is made 0, we can find A as well as C. So for C we need I1 and V2. So V2 we know. What is V2? 15.2. The one we must find is, so I'll type here V2 as 15.2. So we must find I1. So go back, delete this as we found I1. Now if you see here, I1 we have to find in clockwise direction, our current going right. So where you have to place, I cannot place here, a junction gives 0. So I'll place at the end of the element. If I place on the wire, it will give error. Place the end of the element, it gives current from this end to other end of the same element. I repeat, it gives current from this end to other end of same element. That means it will give in upward direction. If I place the resistance current marker here, it will give current from this end to other end of same element. It will give current going left. So in that way I will place my current marker here, simulate. I am getting the current as 3.8. So 3.8 divided by 15.2, we get same ratio, that is 0.25. So you can change your input voltage from 19 to any value, you still get same ratio. Okay. Now we have to make V2 0 to find B and D. So how do you make V2 0? By short circuiting it. Okay. So now let's find B. So V1 and I2. Okay. So V1 we know, we have connected it. So this is 19. So we have to find I2. Now where is I2? In this direction, right? Now I cannot place current marker here because it will give error. So what we can do, we can place a 0 volts, which in turn acts as an element. So now I have to place the current marker in which direction, going towards left. So I must place the current at this end. So this gives me I2. I2 is minus 8.44. So minus I2 is 8.44. So 19 divided by 8.44. We get 2.25. As its 0.4 is recurring, is approximately correct. 2.25 is the correct answer. Now to find D, is I1 and I2. So I2 we have found, it is 8.44. So what we must find is I1. Remember, this I1 is different, this I1 is different. Now how are they different? Now for this I1, the current I2 was made 0. It was open circuited at the second port here, that means here it was open circuited. Now for this I1, V2 is made 0, that means this has been short circuited. So the electric circuit has changed, thus the value of I1 will also be different. So now we have to find I1, place it here, simulate. It is 10.556. So we get 1.25 approximately, sorry 1.25, yeah, which is correct. So this is how one has to simulate. So remember, this I1 and this I1 both are different because here I2 is made 0, here V2 is made 0. This V1, this V1, they are same because it is input voltage. So this is how one has to simulate the two-port parameter. Remember this we are placing only to find the current in this towards left direction, nothing else. Remember, for any hardware lab, the circuit must be inspected by lab inspector or faculty before you energize, either it's SCE or CIE. Thank you for watching the video. Please subscribe the channel to enhance your knowledge further.